Welcome to June 8th's LeetCode challenge. Construct binary tree from Preorder and Inorder Traversal. So you're given two integer arrays, Preorder and Inorder, where Preorder is the Preorder traversal of the binary tree, and Inorder is the Inorder traversal of the same tree. Construct and return a binary tree. So there's still a little bit of recap on Inorder and Preorder traversal here. So we have so Inorder traversal is let's go with Preorder first. So Preorder traversal goes like this. You start from the root, and then you go 3, and then you take 9, and then you go back to 3, and then you take 20, and then you go to 15, you take 15, and you take 7, and then you go there, and then you're done. So it's starting from the root, you traverse to the left, and then you take the first number you see, and you put that into the array. So it'll be 3, 9, 20, 15, 7, and you're done. So that's basically how you do it. You don't take the same node twice. Inorder traversal means that you're taking the order, the array in the order that you see it. So basically, if you go here, it'll be 9, then 3, then 15, then 20, then 7. So there's a way of traversing through that. So you take the numbers in order. So given these two traversals, you want to reconstruct the original binary tree that's given. So it's this right here, and you want to basically you want to reconstruct the binary tree, which has the appearance of the root and the left node, and then the right node, and then the left node here, which is null, and then the right node here is null as well, because 9 doesn't have any subnodes. And then take 20, and then you go to 15 here, and then 7. So you want to return the binary tree. So let's look at it in more detail here. So we know that in Preorder traversal, the first number is always the root of the binary tree. So we'll use that as an important point there. And we also know that if we look for 3 in this one, everything to the left of 3 here, such as 9, is on the left side of the tree, while everything to the right is on the right side of the tree. So we know that as well. So let's kind of copy these two down, and we'll walk through it together. So we take 3 out being mid, and we take 3 out here, so we can make a divider. So everything to the left of this is on the right side, and everything to the right of this is on the right side of the tree. See, and then we have the nodes down, and we know that this is index size 1 on the left. That means that 9 here, it could be divided even more. So we know that 9 on this side has no children because it's the size of 1. Then we move on to the right side, right, size of 1. Then move on the right side, so we're looking for the mid of this point as well. So we look for the mid, however, look at here. If we take 9 out now, 9 is done with. We see this is the first index of the Preorder tree on this side when everything is removed, and that's the midpoint of there. And we look for the midpoint here, we find it right here. So we know that the right side children of 20, we can divide there. Everything to the left of 20 is 15. It's on the right, the left side of 20. Everything to the right side of 20 is right here. So we take out there, and now we have 15. So we know 15 is size 1, and 15 here is the first index. So we know that 15 does not have any children node. Right? If we remove that, and now we only have 7. So you have 7 on the right side, and 7 here of size 1. We know that 7 is on the right side of 20, and there's no children node for that either. So we're going to use this idea and recursively go through the binary tree in order to build the binary tree. So also note that Preorder and Inorder consist of unique values. So there's no repeating values in there, and it will be important and it'll help us search for unique values and construct our tree. So let's get started. So we want to do an edge case first. So right here, basically, if they're empty, so we want to search if not preorder or not in order, then return none. Alright, next you want to find the root of our tree. So we know the root is always gonna be the tree node, the first index of the tree node, of the preorder list. Preorder. Because we know right here, in the preorder, the first index 0 here is always the root of the binary tree. So from that, we can start building our tree using it. Alright. Next, we want to find the mid. So I'll call it mid, so the middle of each tree. So that's what we're going to use for a recursive case. So we're going to look for our in order. And we want to find the index of our preorder at index 0. So we want to find, once we have the first index here, 3, we want to find the index. That's why unique values are important, because we want to find 3 in the in order, right? And we want to find the index of that, and that's 1 right here. So we know that the first number in our preorder is the root, and we want to find that, that's the middle, and we want to find that in the in order list, which is right here, which is what this line of code does. Alright, next we want to iterate through it, so we want to find the root of the left side, and assign that is equal to self. So we're going to use a recursive case here, build tree. So we call our original function, build tree, and we take in our preorder. So we want to start after the first index, so taking the slice there of mid plus 1, and in order as well, in order, from all the way from the beginning to mid. And we want to find the root of the right side, so we do the same things, a similar method, build tree, taking preorder from mid plus 1 to the very end of our array, and then in order. We take it from mid plus 1 all the way to the end as well. And then at the end of this, we want to return root. Right, in order. Oh, I have shift on. Alright, that looks to be good. Awesome, accepted. So time complexity would be, you have n here plus n, so big O of 2n, or big O of n as you would say it. And space complexity, we are saving it n times, I believe, so we do traversal it to recursively, so I think it's also big O of n as well. Alright, that's it. Have a nice day.